Hello again everybody, and welcome to another Sunday night short. And well, I'm calling this number 30. I think that there was one I didn't count because it was a couple of days late, but done a little bit more work on the compressor enclosure, but I'm afraid I haven't got any footage of that. I've got three sides built, and I've got ideas of how it's going together. I've got to get some wood treatment on the bits and pieces, and then we'll see where it goes from there. Been at a Marini Riders Club committee meeting today, so haven't got anything done. It turned into a bit of a social chat after the meeting, so I only just got home in time to eat, and then come up here and edit some stuff I did yesterday, which was for a viewer of mine, Oliver Boatwright, and was asking about a way of setting up a foot switch and brake on his lathe. And I know he, by the time I'd got all my ideas together and shot my ideas of how to do a circuit, he'd come up with some ideas of his own, and I'll hopefully hear back from him how they work out. They look as if they should work. You know, there's loads of different ways of doing things. What he proposed is certainly not the way I would have done it. That doesn't mean it's not a perfectly good way of doing it. I like mine, but then hopefully I would do. So that's going to make up the bulk of the video, and the only other little thing I've got to show you is something I ran off on our 3D printer at work. So I'll move the camera and bring it in close and give you a little look. Okay, loads of you are going to recognise what this is, and obviously there are various bits of mounting hardware available to go with these. One of the things that isn't as such available is a handle for operating the camera handheld. Well, you might have seen some footage of the 3D printer that I'm playing with at work, and the last thing I printed out was this, which is a handle for the GoPro, and this is straight off the printer. You can see it's got a big flash line round it, which is the what they call brim. It's deliberately painted wide to get it to adhere to the bed better. Before I did that, I was having problems with this end peeling up and this end, because you can see there's a distortion in the shape caused by the plastic curling as it cools. You know, thermal management is quite an issue. You'll also see that there's a shift in this. The black's not showing up brilliantly well with the white, but there is a layer shift in this just there, and that's caused by the head actually catching on the tops of these holes as it prints. Though I was having layer shifts due to it missing steps. This one, yes, it missed steps, but it was because of a physical obstruction, but we still got a usable part out of it. And I haven't touched this part and cleaned it up in any way, but even so, you can see that the attachment would slot in. It can't go in all the way because of the flash down here, but with a little bit of clean up, that'll work just fine, and you've got a handle. Now, in terms of material costs, there's I would estimate about 70p, maybe $1 worth of material there. But it did take 2.5 hours to print. But once you have got your 3D printer set up and are confident that you can just walk away from it and leave it to get on with it, does it matter that it takes 2.5 hours? You can be doing something else. But I might have a go at printing another one, see if we can get a slightly better result. But all you GoPro users out there, this handle was on Thingiverse, but I'm sure there are other versions, and a lot of the mounting hardware, there's 3D printed versions. So hopefully you found that interesting. Okay, one of my viewers, Oliver Boatwright, sent in a question about setting up a foot brake on his lathe, and he's using one of the cheap Chinese Yuan Yang inverters or VFDs, like the one that I've got on my Harrison, and I've got one on my Longchang First Bridgeport clone, and a couple of other things. And certainly for the money, when you can pick up the 3 horsepower unit for about £75, they're good value for money. I've had no trouble with them. Let's go to the board and I'll show you what Oliver's setup is at the moment. Now he's got a lever on the carriage, which is a single pole 3 position, so forward, stop and reverse, and those are wired up to the inputs on the VFD as more or less as their standard functions. D1 forward rotation, D3 as stop, and D2 as reverse rotation. Now the inputs have got two, and this is common to VFDs, the inputs can either be maintained inputs or momentary inputs. So if you look at this little table I've drawn here, when a terminal is set to function 01, that's run, but that needs to be maintained, so that'd be closing a switch and leaving it closed. 02 and 03 forward and reverse or momentary, so you make a push button contact to that terminal and it runs the function until something cancels it. Now just because it's a momentary input doesn't mean it won't work with a maintained input. The difficulty then is if you've got your stop function to cancel your forward or reverse rotation, and that's a maintained input, the stop will only work whilst you press the stop button. Now that's fine with this switch because you're going from a forward to a stop or a reverse to a stop. Now what Oliver wants to do is set up a foot brake, which will first have to stop the inverter and then potentially bring in a mechanical brake, and I gave him some ideas about sourcing some components and where he could possibly mount it on his machine. I've only seen a picture of the gearbox end of his machine, so I don't actually know exactly what it is. So he's got a little bit of a problem here setting it up to work. I mean, my settings are, I have a button that sets up to, oh, I should mention, the stop function is a reverse logic. So you maintain the stop input to keep the lathe running, and when it's opened, the lathe stops. That means that you can have any number of stop switches wired in series, all of them operating the stop. So you could have, you know, chuck guards and change gear covers and a foot switch. Your foot brake can run that function. Setup is that the D1 input is set to O2 forward rotation, so I press the button, the lathe runs. Now just because it's forward rotation doesn't mean it can't be overridden by the one that I have written down wrong. Let me just correct that. Forward reverse input, which is maintained, so open contact will be one rotation, close contact will be the other. So in my case I've got a little rotary switch for that. Likewise, you've got all these jog functions, and the difference, these are all momentary, they only work when you've got the input active, and the difference is if you use the jog function, it works in combination with the forward reverse input, but you could use two separate inputs and have two buttons for forward jog and reverse jog, and that's fairly common logic on most of the drives. Some of them are much less flexible, and they've haven't got nearly as many features. Okay, so what Oliver's wanting to do is have a foot brake that will turn off the VFD and then operate a mechanical brake, and it must shut the machine down, and it must stay shut down until the control lever on the carriage has been returned to the off position or stop position, and then back into one of the run positions. And because the output of that switch is a maintained output, that's a little tricky. So what I would propose would be to convert those maintained signals from the switch into momentary signals. And you could do this with timer relays, similar to what people are doing on their compressor drain valves. But something that used to be fairly common in the past, and I've certainly done it, is to use a capacitor to turn a relay into a time delay, either a turn-on delay or a turn-off delay, or indeed a momentary action. And this is what I've drawn out here. So we've got a positive DC supply, an electrolytic capacitor, the relay coil, and the operating switch. So when the switch is closed, there will be a completed circuit and the capacitor will begin to charge, and the current flowing through the capacitor will pull the relay coil in. But as the capacitor becomes charged, the current drops and the relay will drop out again, so you get a momentary action. And I was playing with a little relay on the bench at work, and it was a 2.5K coil and a sensible value that gave maybe half a second, quarter of a second delay thereabouts, was about 22 microfarad, and of course you do need a capacitor that's rated above the supply voltage. Now that works, complete the relay contact there, but the capacitor tends to stay charged, so when you turn the switch off again and close it again, you don't get a second pulse. And the simplest way of dealing with this is to add bleed resistor. I'll draw it in that older style, which when this contact is open will gradually discharge the capacitor such that it's discharged ready for the next time. Now this resistor value is something of a balancing act. you don't want it too small, or it will, once the relay is pulled in, it takes less current to maintain it closed than it did to close it. And if the current through this bleed resistor is enough, the relay will stay closed. And if you get it too marginal, it can sometimes pulse and sometimes not, depending on temperature. If the value of this resistor is too big, then it will take quite a long time for the capacitor to discharge, such that, you know, on a lathe where you're going from off to forward, if you went from off to forward again, it might not re-trigger. So there's a little bit of a balancing act. That's the simple solution. A more complicated solution would be to add a reset switch, which could be part of a relay contact. Then you actually also want to add a resistor to limit the current going through this contact, because even a small capacitor will generate several amps of current when short-circuited, but this can be, you know, say on a 12 volt supply, a 12 ohm resistor would limit the current through the contacts to an amp, and it's going to discharge the cap almost instantaneously. So that's the basic idea, and you've then got a set of volt-free contacts to run off to your VFD. It also has the advantage of isolating the VFD from everything on the machine. And an additional advantage, and people do sometimes run into problems with this, if this is your switch on the carriage, the contacts are not really intended to operate what they term dry. That is, that there's actually a minimum current that's meant to go through those contacts for them to be reliable. When you're switching signal levels like those from the VFD, it can take very little dirt on the contacts for them not to work. Relay contacts tend to be much better, and they do special signal relays which work down into the micro amp range and still maintain good contacts with no real current flowing through them. So this can make the system a bit more reliable, and I've even seen people add a parallel resistor to the relay coils just to pull a bit more current through the switch. Anyway, I'm just going to redraw all this for my proposed solution for Oliver's lathe. Okay, so here's my circuit. So this is the 3-position switch on the carriage, and we'll have a forward relay with its momentary capacitor. Duplicate that for reverse, and then the stop relay, doesn't matter if that's maintained, that would be the equivalent of a latching mushroom stop switch. Just maintains the stop signal all the time. I've drawn it here first of all in its simplest form with the bleed resistors. Now, slightly more sophisticated is if this stop relay was then a 2-pole, then we can eliminate the bleed resistors and we'll add a current limiting resistor and a diode. then we will connect those up to the normally open contact on the second set of relay contacts, and then if I can do this without the drawing becoming too messy, now when the stop relay is energized and these contacts close, it will discharge these capacitors through the diode, and the diodes stop one affecting the other, and the resistors limit the current through the contact. And I think that's about as simple a circuit as I've been able to come up with. So the next step is how you actually wire these relay contacts plus the foot switch into the VFD. Okay, we'll start down here. DCM, certainly on high Yang inverters, that's DC common or digital common, and you string all of your stop switches, which are normally closed, which means that if there's a break in the wiring, the machine stops. Safety interlock, that might be you know, your gear cover, belt guard, chuck guard, whatever. Foot brake, then your stop relay contact, and that's going to D3, which standard setup is to program that as your stop input. So D2 is normally set up as reverse and D1 as forward. So these could equally well be push buttons. That's how it is on my machine. On Oliver's, they're obviously from the carriage lever, but we've now converted them to relay contacts. And all of this circuit is common only to the VFD. It doesn't have anything to do with any of the rest of the electrics, so that keeps the VFD isolated. And once you've got a VFD, there's of course all sorts of clever tricks you can do with auto reverses for power tapping on a pillar drill, and even you could set up electrical bed stops or threading stops, you know, on the lathe, and no end of possibilities. So anyway, I hope that my logic hangs together and that will work for you, Oliver, and good luck.